So we can see right here, cities are X, Y is the elevation. So for part A, given this chart, switch back over.
Hey, sir. I sent you a chat.
We're just starting. So first thing is make sure we know what our definition function is, the definition. Now we're going to do number one. This first question right here. So I'm going to go ahead and write it down. Um, yeah, feel free. There we go. That'll be helpful. Also, make sure that I've got you before you leave. So city is the X, elevation is the Y. So we got Springfield, which is 6451. Albany, 285. Augusta, right? Yeah. 6451. Richmond, 5883. Okay. So there's not much to it, but you should always check when you're given a chart, is it a function? And the easiest way to check is look and see if any of the X's or inputs of the function repeat. These are all different cities, right?
Yes.
So we're good. It is a function. They don't have exactly one output. So if they had two different elevations, that wouldn't make any sense, and it would not be a function. Okay. So part A, all they want is for you to put it in the coordinate form. So let's call it first one spring, just keep it short. 6451. The first coordinate. Albany, 285. Augusta, 6451. Richmond, 5883. So that's part A, no big deal, right? Part B, it says write the domain of the relation. So what is the domain?
The cities.
Yeah, just the cities, right? So write a little set with the braces and just write them out. Order doesn't matter. What is the range?
The elevation.
Yeah, so these are being paired or mapped to their specific elevation. That's all this function does. So you give it a city and it tells you elevation. That's the function.
So when we're looking for the function, it only matters if the x repeats or if the y repeats or both.
The easiest way to think about it is if you see that x go to two different places, not a function.
Okay.
So like if Springfield popped up twice and had two elevations or something, then right. Or if it was numbers, you said, oh, the number one, you have the point 1, 2, and then 1, 3. I'm like, well, that's an X with two different Y's, so not a function.
Okay.
Or D, it is a function. Anyway, so they just want you to put commas, parentheses, otherwise it'll mark it wrong. See, these are the commas I'm talking about. Someone was asking earlier, if it marks it wrong and you have the right coordinates, you're probably missing something, or just delete it all and type it again.
It just looks like you is that like a selection answer, or did you have to type that in?
I don't know, but type it in or select it. Just depends.
Oh.
It won't let me mess with it. This one is a selection, so I want to say this is probably a selection too. So the domain is just the cities we said, right? The range, we're actually typing them. So make sure the brace is already there. Go. Put my comma.
Wouldn't you only put 6, 4, 5, 1 once?
Oops. Yeah, check it out. We have two cities at the same elevation. Did I mess that up? No, it was here. You have two different cities with the same elevation. That's okay. But we should never repeat ourselves, like we said last time. So you're right. Just one time. So this is the alternate answer. This is the proper answer. Any question on this first one?
Yeah, I kind of missed the last part. Like I saw the second to last, but part four.
Mhm.
So just to recap, what would make this a function?
So the definition of a function is every input, every x is assigned one and only one y. So if you see an input or x value paired with two different y's or outputs, not a function.
So the fact that they had like one number would equate to a function.
Yeah, so notice how all these cities only have one elevation. So no problem here.
Yeah.
So you would say yes. So if there's a problem and it violates a definition, then you say no.
Yeah. So if it violate the definition, would it have like two different um, numbers? Like let's say Springfield had two different numbers on the elevation.
Yeah, like if you saw Springfield with this elevation, then you saw Springfield again with a different one, you're like, well, that's not a function. Okay.
Yeah.
All right. Let's go to the next one. This one, similar, but they're giving us points. So first, they want you to write these as coordinates, right? Remember, X and Y for X first, Y second. So you just type them out. So what is this point right here?
-1, 2.
Okay, so you would say -1, 2, and then put another one. Oops, should probably put my comma there. Next point, it's this one right here.
0, 3.
0, 3. Next one.
2 comma 0.
2, 0. This
And
guy.
oh, sorry.
What's this one?
2 negative 4.
This one?
3 comma 4.
Oops. What did I mess up on? Double check. -1, 2, 0, 3, 2, 0, 2, -4, 3, 4.
I think it wants you to use brackets like on the
Yeah,
ends.
you're right. I forgot. My bad. We need a little set. And then the pairs. Okay. So what is the domain brackets?
-1, 2, 3.
2, 0. Well, no, there would be just 1, 2, because there's two X's already. So
True,
just
yeah, we
be
don't repeat
1,
ourselves.
2, 3, and then 0.
2, 3. Yeah, that should be good. Let's check. Okay. What is the range?
2, 0, 4, -4, and 3.
Right, let's check. Cool. So far, so good. Is this a function? Does it violate the definition or are we good?
It the I mean there's a 3 on both of them, and there's a 2 on both of them, and there's a 0 on both of them.
So remember we said if you see an X with two different outputs, your definition is violated.
It's not a function.
It's not, right? You see here we got 2, 0, and then 2, -4.
Yeah.
So that's why it's not. It's because of this specific thing.
Yeah, because of 2, there's already a 2 as a domain.
Yeah, so basically there's a 2 going to two different places. So that's not a function. It's still a relation, not a function. Any questions on number 2?
Not that I know, sir.
All right. Okay, so another way to determine if something is a function is to draw vertical lines through it. It's called the vertical line test. Should be in the videos and in the notes. So basically, if you draw vertical lines through it, and no matter where I draw it, it only hits the graph one time for each vertical line, then it is a function. Do you see that there's no possible way a vertical line will hit it twice, right? Do you agree?
There
So
would be no way to hit it. Yeah.
Yeah, it's impossible to hit it twice if I draw a vertical. So because of that, it is a function. So that's one way that you can tell. So if you were to graph something, you can just look at it and say, well, there's no way. But if I had like a, let's say, let's suppose we had a circle, right? Right away, you should see, no matter where I draw it, it's going to hit twice, right? So if I hit a function or if I hit a graph 2 times, not a function. A circle is a relation, it is not a function. This one here is a function. Any questions on that idea?
So if it's a circle, it's not a function, right?
Circle is an example of not a function, but any graph that is hit twice with a vertical line, not a
So
function.
so like if let's say we have like a quadrilateral, like if we have a U that crosses both, like crosses two sides.
Yeah, let's say we had like a parabola going sideways. That's a horrible parabola, but that would hit 2 times, right?
Yeah.
That's the circle. This will never hit twice, so we're good. That makes sense.
So X just can't repeat itself.
Exactly. That's the real definition. But visually, you can test that by drawing vertical lines. Is this a function?
no.
Let me
There's
see.
nothing that there's like it looks like it crosses the X side a lot.
It does, but would a vertical line hit twice anywhere?
No.
It,
No.
So it looks like we're good, right?
it is a
Yeah.
function.
So it is a function.
It is, yeah. It only hits 1 time. So that's this, what we're doing right now is called the vertical line test. This is literally a vertical line, so of course not, right?
Correct.
I would hit it infinite times, so that's no.
Yeah.
What would they? Okay. Now we have a set instead of a graph. Set of domain, set range. If the value x goes to 4 different spots, is that a function?
No.
No, because we said definition said what?
You
Raw
can't
inputs, right? Oh, go ahead.
say input.
Yeah.
It has multiple inputs, so therefore it is not a function. It violates that definition.
Yeah. All inputs must have in the domain must only have one output assigned to it. Otherwise, it is not a function. This has 4 different outputs. So no. What about this one? Is that a function?
No, it is not.
Why not?
Oh wait,
What's your thought process?
it is a function. Never mind. Each different number shares no repeating. All the domains do not repeat.
Each
Yeah,
x at least has a y.
yeah, each x has only one y, right?
Yeah, that's how it should be.
Yeah, even though this one happens to be the same y, that's okay. Okay, so here we're just talking about notation, which we already talked about, right? I can't remember. We plug stuff in. Do you remember what this means?
That means you replace the x in the equation with that number.
Yeah,
So like the -4 would go inside each x, and then you solve it.
yeah, that's all. So you're just gonna do that with each number. I think we've already talked about this.
Yes, we covered this
We
last
covered it
session.
within a lesson, but this is just like the expansive version.
Yeah, it's like slightly harder, but so let's move on to something else. Looks the same. Here they're plugging in the letter T, so what would you do?
Just
Solve
put
for t.
when putting the x.
Yeah, all the X's would become T's, and that's it. You would just plug it in, and that's it. There's nothing else you can do. Same thing here, right? You plug in the b into your function, you get b squared minus 5b. I cannot simplify it further. So that's not interesting.
So
This one
when
that'll
we
get better.
so
Go
when
ahead.
we do the homework and it requires and we come across that question, will we just insert like 5 parentheses b squared plus whatever is the other part
Yeah,
of
so
the
it doesn't.
equation?
So whatever's in the parentheses is going to go into the x, and if you can simplify it, simplify it, and if you can't, then leave it alone. So let's do this one because this one's a little more complicated. I forgot what number this was. 52. This is number 11. 5.3. You write this down. So given h of x equal to x squared plus 3x. Yeah, that looks weird. That's gonna bother me. X squared plus 3x. Find h of a minus 3. So remember I told you, no matter what, you just do what it says, right? It's an a, you plug in an a. Actually, it's an a minus 3, so plug in the whole thing. So you're going to get a minus 3 squared plus 3 times a minus 3. Does that make sense?
Yeah.
Yes.
Okay. So that's 50% of the work right there. That shows me you understand the concept. Now we do algebra. Square this whole thing, right? That means multiply it twice. You can use your uh, binomial formula, FOIL, or box method. I don't care how you think about it, just multiply it out. Distribute the 3, that will give us 3a minus 9, right? 3 times a, 3 times negative 3. Now let's do this part. Okay, so a times a times negative 3, 3 times that, 3 times 3. Y'all have any issues with the multiplication part? These are 9s. The rest are a's. Sorry. These are gone. One of these are gone. That's all we got, right? Left.
I'm sorry. How did you get from the second to the third line?
All right, so you understood this part, right? This little piece.
No, I'm a bit lost.
All right, so we plug it in. So now we got to do some algebra. So distribute the 3, 3 times a, 3 times negative 3. So I did that first right here. 3 times a is 3a. 3 times a negative 3 is negative 9, right?
Okay.
So that's just a distribution. Square this part that came from this part of the functions. I got to square the input, a minus 3. Squaring means multiply the same thing twice. Multiplying this twice would be distribution, or I mean, you can use any method you want. I basically showed FOIL, so a times a, it's right there, it's a squared, and then um, a times negative 3 is negative 3a. Then I went to the next one, negative 3 times a is another negative 3a. Negative 3 times negative 3 is a positive 9. So that's why I got 1, 2, 3, 4 terms out of this multiplication. And then these are from earlier. These two. Does that make sense?
Yes.
So at this point, we combine like terms. Positive 9 minus 9 are gone. Minus 3 plus 3 are gone. We're left with just two terms. So our output will be that's it. Any questions on number 11? We'll write some steps here. Distribute three on these two. FOIL / multiply. Combine like terms. This product here, or the square, can be done in many different ways. I don't care how you do it, just make sure you show your work or you do it right. Or both. You guys cool on 11 then?
Yes.
It looks good, sir. You just combine it. You cross it out.
Cool. All right, let's move on to something else. Here we kind of already talked about intercepts. So I'm gonna move on to 13. Was that 13? Oh, here we go. Here's 13. So what is the domain of this graph here, of this function?
This is where I got confused on. I'm not sure if the domain is where the circle is or where the line is. I know the domain is the whole X line, but it don't make sense.
Yeah,
Uh,
basically it's remember it's kind of like the parentheses. You start right after. So you would say,
so the dot indicates where we start.
yeah, it's a starting point. It just if it's solid or open, depends if you include it or exclude.
Okay. In this case, do we include it or exclude it?
Since it's
Since the dot is
open,
open.
you don't include it. You put parentheses on it and then you keep going to the right.
Okay, so then it would be
So we're starting from here and then we keep going. Actually, that's the wrong line.
so it's like from last lesson where it was the negative or positive infinite or negative infinite.
Yeah,
So this is just it but graphed instead of on a line.
exactly. So now we're expanding the idea.
So so how you found negative? It was just crossing. Like,
Yeah, you
like how
just
did you
figure
find
out
the
what are all the x's it's covering, right?
like when it goes down to the -1 on the x, then it would just be -1 on the x, and then the
Yeah,
y
because
was
this is the
infinite.
point -1 comma 2, right?
Hmm.
The domain only cares about x's, so I'm only looking at the x. So the lowest x that I see is -1, and then it keeps going forever, so I cover all the x's. But I don't
And
put a
then
bracket on this.
like when it tilts down like that, and then it just like goes to 2, and then suddenly goes up. That's considered infinite.
Yeah, if they have an arrow like this, that means it keeps going.
All right.
Okay, so range, I put the answer by accident, but same thing. What is the lowest value that you see on the graph? So the range is up and down, they're the y values.
The range lowest would be 1.
Yeah, so basically right here and it shoots, it goes upward forever. So you would say bracket 1 to infinity,
So the
right?
range is the lowest value.
Yeah, for a domain, it's the lowest x, and then wherever it stops, or if it keeps going, then you say so. Range is still the lowest first, but up and down. So, okay, what's the lowest, and then what's the highest? If it keeps going, then you say so.
So like if it crosses the y-axis and it's like it hits 1, then that's the y, and then it goes infinite.
Yeah, because this is the lowest it ever got, right? Because it shoots up forever.
Yeah.
So 1 is the lowest range value, and it keeps going up. So everything is included starting at 1 and after.
How do you know when to put a bracket and when not to?
If there's a hole, then you can't put it.
Every infinite every time it's an infinite, I remember that you're supposed to put parentheses on it.
Yeah, you never put bracket on infinity because it's not a number. The bracket is for a specific number, assuming
Yeah.
it's not open. So the -1 was open, so we couldn't put a bracket. Is there any other questions on this one?
Not that I know of, sir. I think I understand it.
Just let me know, guys.
So if the circle isn't filled in, we wouldn't put a bracket.
Yeah, if it's not filled in, don't put bracket.
Okay. Okay, thank you.
All right, so this one's 14. Determine the domain and range of the function. So same question, but the graph is different. So I know we can't really tell, but this is going down and to the left forever. It's just shoots off so quickly, it doesn't look like it keeps going to the left, but it is. And eventually it's gonna cover everything on the X to the left and on the Y downward. See what I mean?
Yeah.
So the domain is gonna be -infinity to infinity because it keeps going forever.
Yeah.
It goes all the way down and all the way up. So again, -infinity to infinity. Do y'all see why this is true?
Because because on one side you see it, it goes up and down to infinity, but if you flip it over, it goes left and right infinity.
Yeah, so just remember, eventually it's hitting everything. If you change the way we look at it, it's more obvious here. You open Desmos somewhere. Just pick a simple X cube. Okay, so if I change the way we look at it, you see how we zoom in, it's going to keep going to the left forever. It's going to hit all the X values and to the right. Keeps going.
Yeah.
And I don't know, it might be slow or it might be fast. It doesn't matter. It's going to jump and it shoots up. And then once you get the domain answered, range is obvious too. If it goes up all the way forever, then it's infinite. If it goes down all the way, it's negative infinity. There's not really much work to do. It's more of a concept.
Well, unless there's like a circle and like a straight line with the domain and range, it really has no domain range.
Yeah, I mean, they could put a circle in a random spot and mess with you. Then you'd have to break up the domain, but since there's no circles, then it's just pretty clear.
For this one, how did you know negative infinity was the X and the Y was the like positive?
Well, basically, what we're looking at is every single point, right, is being mapped somewhat. So this is, you know, this X, all these X's forever are being covered all the way to the left forever. So if I keep going to infinity, I'm going to cover all of them, all the negatives. But if I keep going to the right, I'm going to cover all the X positive numbers. So that's why it's infinity to negative infinity. But the same thing is true for the Y values because it keeps going down keeps going to the right. Because remember, these are ordered pairs, right? All the x's here are being mapped to some y value down here, right? Just keeps going. Right, can keep going forever and keep going forever. The x's keep going negative. You see what I mean?
Yes.
So if the graph keeps going in both directions, I'm going to hit all the x's and all the y's. That's why it's infinite. Okay. Oops, I had the wrong window open. Dang. My laptop's making weird sounds. Okay. Okay, here we go. So that was 14. So 15. So part A, what are they asking for?
So it's asking to determine -5 and 1.
So this notation right here, what does it mean?
It means x equals -5.
Yeah, so we're plugging it in, right?
Yeah.
And if you plug it in, that means they want the y value. So what
Yes.
is the y value when x is -5? Looks
So
like,
we use so we like find the -5, which is x, and then we map it up to find the y.
yeah, this is the point where we're talking about. -5x is right there. Right up. So the function would give you a 1.
Yeah.
So the output is 1. The location is -5.
1.
Okay, wait. How did you get that? So you just went to the graph, the negative
Yes.
is the x?
Yeah, so right here, right, we just gotta make sure we understand the notation. F of -5 means plug in -5, but we don't have the function. But this graph represents the function. So just find out what is happening to the graph at -5. So here's -5 right there. So the graph is at 1, right?
Yes.
So the output, the y value is 1. The point is -5, comma 1. What about this one? What's going on at when you plug in 1?
If you if so from 1 to the y, it just it would
Would the function be 1, -1?
Yeah, there's the point right here, right? 1, -1.
Yeah,
because cross around with each other.
So
I
the output
see
is
what's going
-1.
on now. All these we just have to plug in for the x on the graph, and then find where the other point intercepts with the y.
Right.
And we use the line for it. We use the line, right?
Yes,
That's
you
a
use
given
the
one.
line.
Use any graph that we're talking about, it doesn't matter. Just go to that location and see what the y output is. 1 is -1, -5 was 1 over here. 0 would be -4, right? Whatever. Does that make sense?
Yes, I get this
Yeah.
now.
So C and D is the opposite. They're giving you the y values. They want to know what is the x that corresponds to these y's. So when y is
Okay.
-1, or there's y right here,
Then it's 1.
yeah. It looks like there's more than one spot, right?
Yes, it'd be 1 and then -3. So when it asks for y, does it want us to try to find all points?
Mhm. So we have 3 points. The y value is -1. First one was -3. The next one is
1,
1. Yeah, that's right. Last one,
3.
3. Okay. Now f of x equal to -1. For x is equal to -3. Same question, they're just phrasing it different. Right?
How'd you get 3 and -3 again?
From the graph. So they're basically asking what are all the x values that corresponds to -1. There's -1. So I hit 3 spots. You see that?
Yeah. So
So
if it's asking for -1, and if it crosses that -1, those are the points.
yeah, so basically -1, sorry, 3 different x values are going to -1. This is what's happening.
Yeah.
So just write down the x values. So right here they want the points where it happens, and then over here they want the actual x's.
hmm
And that's it. Part 3, find all x values for when f is equal to -4. -4 is right here. Looks like there's only one, right? You see any more?
-4 has only one crossing.
Yeah, I think you're right. Oh, sorry. The y value, my bad. Here. -4 is 0 and 4. Zero and
It looks like 2. Well, actually, no.
4.
It just crosses.
Yeah, the x values are 0 and
How'd you get 4 though?
so find where the y value is -4. So here's the y value. So there's 2 spots.
Oh.
At first I was looking at the x, which was not right.
Yeah. Because f of x is equal to y.
Right. Mhm. Last part. Almost. Intercepts, just find out when it touches the intercept. So we got this spot, 0, a -4, 0, -4, sorry, -4, 0, 0, -4, 2, 0, and that's it. -4, 0, 2, 0, 0, -4. Have any
That's
issues with the intercepts?
that's the summary of all the x's.
Yeah, this is whenever you touch the x-axis. Any points or spots you touch the x.
Oh,
Oh, excuse me.
all right.
Now, what is the domain of this graph?
Domain would be
4 and 2.
All the x values.
-5, -4, negative, I guess all the negatives
Yeah, all
from
negatives for
5,
sure.
and then 0, 1, 2, 3, and 4.
But then it jumps up here, so it looks like it covers all real numbers, doesn't it?
Yeah, kind of.
Because it goes to the left forever, and then it goes to the right forever.
So would this just be negative infinity and infinity?
Yeah.
So despite that weird gap, it would still be considered negative infinity, positive infinity.
Yeah, because they include 4 right here, and then they start right after 4 over here. So there is no gaps when it comes to the x values.
It's yeah, and it was just weird because there was a gap between the y, so it was just
Yeah, when it comes to the range, we got some gaps. That'll be different.
yeah.
So right here, we can see that it goes up forever. So the range will contain infinity, but it won't contain, and it will contain everything in between here. But what is the lowest y value?
-4.
Yes.
This is the lowest it gets, and then it just keeps going forever, right?
So then would it be infinity -4?
The most negative always goes first. So -4, and then the largest, most positive goes second. Oops, maybe I made a mistake. Oh, put 2 negatives. Probably what it is. Are there any questions on what we just did?
Um, where'd you get -4 from? Is it from the bottom right that you got it?
It was asking for the lowest range.
Yeah, whenever we do range, you look at the lowest on the vertical, the
Yeah.
lowest y,
Yeah.
and then the highest y. Since
Yeah, I
this
was just
circle
double
keeps,
checking.
since this keeps going, it's infinite y. This is the lowest it ever got, and then it's these two spots are the lowest. So -4, and then up.
Yes.
All right, that's 5.3. Take a 10-minute break, and then we'll start the next one. Start at 4:25.
All right.
So if it is a number bigger than 1 in front, then it's going to be a vertical stretch. If it's a number less than 1, it would be a vertical shrink. If it's plus inside, it's a horizontal shift to the left. If it's +2 outside, it's a vertical shift up. Okay. So in the homework, See, they're saying this is vertically shrink. It'll shrink. It shrinks the graph vertically by a factor of 1/8. Assuming that this is the original.
I have one question, though it's not about this assignment. It's about the Alex McGraw-Hill homework and stuff. Is this like, are we reviewing like part 2 of the homework or something, or is this like extra stuff?
No, this is the homework that you'll be working on.
We're
Next.
just talking about the homework, but
Right.
in a all right, because
So
I was
I
just like,
So remember, you're gonna watch the videos to see the lecture, and then in class we're gonna try to solve the homework. Okay.
Alright.
Forget. Otherwise, it defeats the purpose. That is number 57. So here's the same type of deal, right? What is the original parent?
It's the expert as well.
Yeah, it looks like, well, the original is right here. Well, here's the function, right? This is a square root type, right? So this is the parent that they're manipulating. You're taking the original and doing all kinds of weirdness to it. So here's the OG. Now, first thing, horizontal translation shift. So that's this inside part is shifting it to the left, right?
yeah,
Okay. Then it says the stretching. It's a fraction, so it's a stretch of 1/9. Vertical translation, it'd be down 3.7, right? Let's see if we got it. That's like my stretch. Compress. Okay. Anyway, is that making sense? Is that okay? Sorry, I'm getting groggy over here. Do you have any questions on what causes shifting, stretching, or reflections? We didn't talk about reflections. Do you remember when things reflect?
Isn't it just mimicking it in the positive and negative aspect? Like,
Pretty much, yeah. You just if there's a minus in front, right, it just switches. So if you have a parabola and you put a minus in front of it, it's a vertical reflection. Okay. If you have a minus inside, it has to be an odd function though. Yeah, the blue one, if there's negative inside, it'll just reflect on the y. See? Just turns.
To use Desmos when doing our homework to see whether it stretches or compresses, because I understand, but also I don't know how to tell just by looking at the fraction.
Yeah, I think graphing it will help. But yeah, just look at the notes that I have for the compression and stretching.
Okay, thanks.
Mm-hmm. And I'll send you more if you need them. Just let me know. Okay. That was number 58. Okay, last one, and then we'll call it a day. Can you see the homework?
You mean what's on the screen?
Yeah.
I see it.
Okay.
When it's a negative, it's considered a -1, right? Like on the outside, like an
Yeah,
invisible one.
so the -1, yeah, it's a -1 there. So what are they doing to the x squared?
They have an x minus 2, which would mean that it would be going to the right 2 units,
-2.
which
Yeah.
is going to the right 2 units.
Three transformations in the following order. So it's being shifted up 6, being reflected on the x, right? Because that's a minus,
Yes.
and it's going to the right 2. And at that point, they just want you to do it. So mind reflection, translation, we said +6 and -2. So -2 is +2 to the right, +6 is shifted up 6. The minus in the front is the reflection on the x.
Yeah.
Okay, so that's 6.1. I'm going to take roll. If you have any homework questions or whatever, let me know.
Can I always chat you like on Remind if I need help, like if I need extra assistance?
Yeah, you can always just like screenshot a question and throw it in there or whatever.
Yeah.
And if I'm busy, I'll just get back to you later. No big deal.
Yeah.
All right. Abigail Carranza,
Yes.
Mia Acosta,
Here.
Leslie um,
Here.
Zapata, Katie Gaitan, Alejandra Garza,
Here.
Luz Gutierrez. Oops, okay. Abigail Hernandez,
Here.
Malaki Johnson, not here. Oh, there he is. Dania Lopez,
Here.
Abigail Carrion,
Here.
Jalen Mora,
Here.
Tiana Morton, not here. Clarissa Mungia,
Here.
Clarissa Nevares,
Here.
Gabriela Palacio,
I'm here.
Liana,
Here.
Julie Requejo,
Here.
Kayla Reinero,
Here.
Amanda Rodriguez,
Here.
Ariana Rodriguez,
Here.
Connors, Oh, Connor. Excuse me. No.
Are you calling me, sir?
Yeah, I'm taking a roll.
Oh, sorry. I here.
Carl Thompson,
I am here.
Abigail Torres, Melanie Trujillo,
Here.
Melanie, sorry.
Yes.
I don't know why I did that.
You're fine.
That's Celine Vidalis.
Here.
Tyler West.
Here.
Okay. Let's see. Just one last call. It's Katie Caitan here, Luz Gutierrez, or Tiana Morton.
I'm here, Katie.
Katie. Okay, got you.
Luz had commented in the thing that she says she's here.
Okay, got you. All right. All right, guys. If you have no questions, you can head out. I sent y'all last week, Tuesday's lecture and notes. And I sent
Remind.
some PDFs as well. Yeah, on Remind. So if you log in on your computer, you can download and watch the videos and stuff.
All right, sounds good.
All right. To double check, you did get Carl Thompson right. I don't know if my mic picked me up when I answered for attendance.
Yeah. Gotcha.
All right.
Last class, you marked me absent, but I'm pretty sure it's when I stepped out because my son was crying. I didn't hear the roll. So
Rodriguez? Let's see.
yes.
Ariana?
Yes.
Okay, I got you from last time.
Okay. Thank you.
Mhm. See you Thursday or Tuesday. I don't know what day it is. Excuse me.
Which assignment do you want done by next Tuesday? Is it
The ones we just talked
the
about. 4 and 5.
5.3?
1 through 5. And if you can look at 6 and 7, that'd be cool. Or at least the videos.
Okay, so then we just need to do assignment 4 and 5, and then we're done until we start going over 6 and 7.
Right.
Okay. All right.
I'll see you then.
That's everything, sir.
Yeah, we'll stop here today.
All right, sounds good. I'll go ahead and finish my other two homeworks because I did the first one, and I'm just gonna do the second one today, just to take my time because there's a lot of work I have.
Just make sure you don't fall behind. You'll be okay.
I'll try. I had like 4 assignments that was given to me by my English, and it's mixing up with my other classes. So I'm trying to find the time.